Okay, we're going to actually do 7-4, and I'm going to throw in part of 7-6, kind of intertwine it because it all kind of goes together. I'm actually going to take part of 7-6 and put it into this section and part of 7-6 into the last section that we're going to do as well. Okay, we're kind of splitting and dividing that into it. We're going to spend today and tomorrow going over this section. Wednesday, we're going to kind of recap everything so far, just because this section's got a lot in it. Then Thursday, Friday, we're going to finish up the last two sections. We're going to review on Monday, possibly Tuesday, test Wednesday-ish next week. Okay, so seniors, I know you guys, Friday is your last day in here, and not you, but seniors. Seniors, we still need to make sure we're taking time to learn what we're doing in here because it is still important for you guys to pay attention. You're still part of the class. You're still getting the homework grades, the daily grades, so make sure you're not throwing it all away, seniors. Okay? All right, so here we go. 7-4 is our different properties of logarithms. So we're going to mainly focus today on those properties. And then there's also the change of base formula, where even if you didn't have the graphing calculator, which can figure out the different bases for you, like the quiz, there's actually a way to do it otherwise. Even if you just have a scientific calculator, it can do it too. So I will show you that in this section. Probably not till tomorrow, though. All right, so properties of logarithms. They're similar to like your exponent properties. That's how I always remember them, because I think back to my exponent properties. So if you look at number 1, if I have x squared times x to the 5th, what would you tell me that is? Be x to the 7th, right? If it's a multiplication property, you added them. So that's kind of what we're looking at here. When you have logs, log base b of m times n, well, multiplication problem, you added exponents. If it's a multiplication, these two things are being multiplied, you can pull these apart. We're going to be expanding and condensing these, either taking them into 2 or more logs or pushing everything back into 1, because that's how it's easier to simplify and solve them. So then you would add when you kind of pull those apart. Vice versa, if I give you this and you're like, oh, there's a plus sign in between, well, plus sign when I push them back together means they're a multiplication problem. It multiplies them. Okay? Same thing with number 2, x to the 5th over x squared, you would tell me is x to the 3rd. You would subtract your exponents, right? Same idea. If it's a division problem, you subtract the two parts of the logs. Notice the log and the base, those stay the same for both of them when you're splitting them apart. Okay, likewise, if I give this to you and you see the subtraction, you need to recognize, oh, that goes back to division. Notice the order, it would be m minus n, m divided by n. The way that you would read them is the order that they go in. And then x to the 5th squared, what would you tell me this is? X to the 10th, you would multiply. Okay, this one's a little tricky, but it's the same idea. If I have an exponent, right, this was raised to an exponent, the exponent then, we always take that and kind of throw this out into the front because now it's being multiplied. You guys see that? Now it's multiplying times it, just the way that these are multiplied. So these are your 3 main properties. This is what we're going to focus on a lot today and tomorrow. You're like, those are easy. Why should that take me that long? They get a little tricky because you throw all of it kind of into one. We're going to have to practice being able to expand them, where you separate every single piece into the different things, or if I give it to you expanded, can you bring it all back together condensed? Okay? So, what is the expression written as a single logarithm? So if I have log base 4 of 32 minus log base 4 of 2. So what we want to do is we want to be able to condense them down to 1. So since it's subtraction, what does that mean when it comes back together? It'd be log base 4 of how does subtraction come back together? It'd be 32 over 2. It goes back as division. What is 32 divided by 2? 16. Log base 4 of 16. Can you simplify that at all? 4 to what power equals 16? 2. Holy smokes, does that thing go all the way back down to 2? It does. It's just 2. So it's important that you can take your properties and you can condense them down until you get something that you can actually solve. Now, can you always take them down to an answer of just 2? Not always. But that's what we're trying. We're trying to take them down as far as we can. All right, so next one, 6 times log base 2 of x. Let's just take one piece at a time. Because when there's a number out in front, where did this come from? Look back at your properties. She's doing little air numbers back there. What's she doing? It's an exponent. This actually is log base 2 of x to the 6. Right? If you go back to your properties, if there was a number out in front, that came from it being an exponent on the other part of the problem. All right, so let's take a look at that. So the number out in front actually came as an exponent. That's where it's from. So let's go one step at a time. Plus, so that means if there's a 5 out in front, where did it come from? An exponent. That's log base 2 of y to the 5th. So if there's a number out in front, that's an exponent. Throw it back up on top as an exponent. And then if I'm looking here, there's a plus sign. If there's a plus sign, how do I push those back together? What operation? Multiplication. So that comes back together as log base 2. And then it's going to be x to the 6 times the y to the 5th. We pull those back together as multiplication. And now it's written as just a single log base 2. Okay. Now, can I go any further like the first one? 2 to what power equals x to the 6, y to the 5th? That doesn't make any sense. I can't do anything else from there. Okay, next one. Log base 4 of 5x plus log base 4, 3x. So is there any exponents I need to throw back over? No, because there's no number out in front, so I don't have to worry about that. Okay. There's new settings. It's taking me a while to get used to where those things are. Cool though, right? All right. So there's no exponent that needs to be thrown back, so I have a plus sign. Where does that go? That's multiplication. So log base 4 of 5x times 3x. Can you simplify that at all? What's 5x times 3x? Good. Log base 4 of 15. Ooh, my picture, I think, got over top of that. There it is, x squared. Okay, but do you see how we took something that was spaced apart, we were able to condense it down to just one log and then the number? Michaela? Everything that we're doing, they will. Otherwise, you can't put them together. They're considered not like terms. All right, how about the last one here? 2 times log base 4 of 6 minus log base 4 of 9. Do you see any exponent that needs to be thrown back up top? Yeah, that first one's got an exponent we need to throw back up there. All right, so let's do that first. Anytime you see those numbers out in front, let's move those first. So it's log base 4 of 6 squared. What's 6 squared? 36. So I can write that as log base 4 of 36. Okay, minus log base 4 of 9. If it's minus, that makes it division. So log base 4 of 36 divided by 9, which is 4. Log base 4 of 4. And 4 to which power is 4? It is 1. Got it, girl. But today's a lot of practice of just those properties, one at a time. If there's a number out in front, put that exponent back. Okay, it's addition, so multiply them. Subtraction, you divide them. And keep going as far as you can. Sometimes you can go all the way down to a number, sometimes you can't. It just kind of depends on what the values are. All right, so let's use the properties of logs to rewrite and simplify these expressions. All right, so looking at these, now we're going, notice right now they're starting with a single log and there's stuff going on, right? So let's take that single log and let's expand it using those properties. So we're kind of doing the opposite of what we just did. So log base 3 of 9 squared times 2 to the 4th. Okay, well, we know that this multiplication, which means how do you separate multiplication? Adding. And if there's an exponent, where do they go? They go out in front. So to start with this one, let's do this first part. Where's the 2 going to go? Out in front. All right, so we're going to have 2 log base 3 of 9, right? Exponents get thrown out in front. And then instead of multiply, it's going to be plus. Do we have another exponent to throw out in front? Yep, so it's going to be 4 log base 3 of 2. All right, so looking at that, can I simplify anything? Any of those evaluating? 3 to what power equals 9? 2. So that means this becomes 2 times 2. Right? Because 3 to what power equals 9? It's 2. So the whole log piece kind of goes away because that answer is 2. What's 2 times 2? That is 4. Plus 3 to what power is 2? Can I do that one? No, I can't do that one. So it's going to stay 4 log base 3 of 2. The ones you can simplify, do. If you can't, you can't. Okay, but it's really telling me if you can do that evaluation part as well. Okay, how about the next one? Log base 7 of 1 over 147. All right, so right away, what'd you say? I know, it's kind of funny, right? I'll make it go away. There we go. All right, so we have log base 7. It's a division problem. How do I separate those? With subtraction. 1 minus log base 7 of 147. So can we simplify any of those, right? I just took the division, pulled it apart as subtraction. 7 to what power equals 1? 0. So do I even need this? No, this whole piece right here is 0, which means I don't really need it. So I have negative log base 7 of 147. Does 7 to 1 some power equal 147? Again, if you're not sure, grab a calculator, type stuff in, see if you can figure it out. All right, so 7, you want to play around with 7 squared, 7 cubed. Does anything equal 147? No, it doesn't. So this one will simplify to just negative log base 7 of 147. Now be careful, don't lose that minus sign in front of it though, okay? All right, and then the last one down here. All right, log, what's the base on that log? 10, good. If there's no base there, we know it's a 10. 6 over 200. So how do you separate division? Subtraction. So log of 6 minus log of 200. Should I separate it like that first, or should I simplify it first? Was there a simplification you could have done before we split it? Yeah. Simplify your fractions. 6 over 200, how does that simplify? 3 over 100. So log of 3 over 100. Will that make it easier to simplify on the next step? Yeah. So that becomes log of 3 minus log of 100. Okay. You said the base was 10, right? Can I do 10 to some power equals 3? No. Can I do 10 to some power equals 100? 2. So this is just going to become log of 3 minus, 2. Because 10 to what power equals 100? That'd be 2. What? We're done for the day? No. All right. So let's get some practice expanding now. We're going to kind of just work back and forth, expanding them, condensing them, expanding them, condensing them, getting practice. This one got a little harder. log base 4 of 5x cubed y. How many different log pieces? How many times will I write the word log? 3. Because how many things are being multiplied together? 3. Will there be an exponent to throw in the front of any of them? On one of them. You see the one exponent? Oh, gotcha. All right, I just want to make sure we're clear on how that works, though, okay? So if I expand this, we're going to do each piece separately, okay? And so we need, there will be 3 logs when I write this down. So it's going to be log base 4 of 5, then what? Plus 3, good, because the exponents get thrown in front, 3 log base 4 of x, then what? Plus log base 4 of y. Okay, so step 1 is we're going to split that whole thing apart. And then don't just stop. We always want to go back and look. Can you evaluate any of them? Does 4 to some power equal 5? No. 4 to some power equal x? 4 to some power equal y? No. Okay, but if there are, like, especially when you get the numbers in there, you want to double check those, because sometimes you can simplify them. Isn't he cute? Well, I wasn't going to say anything. Look, now it looks like he's holding it. Did you see him? The little pig's holding on to it. All right, so why don't you guys try this one? Log 3x squared y. Take a second, see if you can expand that thing fully. All right, guys. So did we figure out how to expand this one? Marcus, what you got? What'd you write down? Just like that. How do you do? I did perfect. Nice job. What? Very nice. All right. How about that one? Oh, wait a minute. What's that weird symbol on there? What is that thing? A radical. All right, let's talk about this for a minute, okay? Because things got weird in this one. All right, so we work with exponents all the time, right? Because where does an exponent go? It goes out in front. Wait a minute, wait a minute. Not a 2. Radical, square root is what power? No, that would square it. Square root. Oh, where are you guys at? Nobody? Nothing? One half? Roots grow underground? Okay, say louder next time. Be confident. Yeah, guys, anytime you see something with a radical and you have to rewrite that, make sure you flip that into 1/2. What if it was a cubed root? It would be 1/3. Do you guys know that chicken's name? Have you guys seen Moana? Did you watch it? It's so cute. Chicken's name is Hey Hey. He's really dumb. That's sad. Yeah, he falls in the water a lot. He ate rocks. He's trying to eat food, and it's like here, but he's like hitting the ground over here. Like, he's not smart. But he's my favorite character on there. He's so cute. No, she won't let him kill him. She protects him, even though he's not bright. Okay, so here we go. So how on earth do I figure this one out? There is going to be a subtraction. How many logs will it take me to separate the top? 2 to separate the top, and there'll be another one for the bottom part? Yes, there's going to be an adding and a subtracting. Oh, she loves to look at that. Look at this. She's like... Now, how important is it for me to recognize that the 3 times the x, that adding part, actually stays on the top? Because that whole thing is being divided by 7, right? So that means I'm going to have what as part of it? You're going to have parentheses to hold that together. All right, so let's go ahead and see if we can break this apart. What happens to the half? It's going to go out in front. Now, does that half go to just the 3 or just the x or both? Both. So when I split this, it has to go on both of the logs because this half goes to both of these. So I'm going to have half times log of 3, right? Because it goes to the 3. How do I split apart this 3x? Plus half log of x, right? Because that half goes to both. But I want to make sure that added part stays together, right, as one group. How do I group that together? Parentheses. Because all of that really needs to be on the top, right, when I go to do the division. How do I separate division? You subtract. I'm going to run out of space. And then, do I write just 7? Log of 7. Oh, move that. Getting used to my new board, my new software. Log of 7. Oh, it went back to fat ink. Fat ink. I need to play around with the settings to get it set by default to the skinnier one. All right. How are we doing? Does that make sense? The half had to go for both the 3 and the x. I had to have parentheses to keep the whole thing grouped as the top. All right, so take a look at the next one on here. Log base 5 of 2 radical x. Take a minute, give it a try. All right, guys, what did we come up with here? What's the first thing I should rewrite? Anytime you have a radical, you should rewrite that. All right, so one step at a time here. Log base 5 of 2x to what power? Half. Does the half go to the 2 and the x or just the x? Just the x, because that was the only part that was under the radical, right? How many logs will this separate into? 2 logs. Will we have any exponents to throw in front? 1 of them, right? So you're going to have log base 5 of 2, and then plus, good, because it's multiply, so it changes to plus, half log base 5 of x. Can you simplify 5 to what power equals 2? No. Okay, and then that's got an x on it. But always double check, okay? Once you've expanded that, be like, wait, can I simplify any of these? Because every once in a while, I want to sneak in there, and you're like, oh, yeah, I missed that. All right, let's practice a little bit of condensing our logs. Yay, you need to be excited. All right, oh, so you have 1/2 log of x plus 3 log of x plus 1. Did you say it's cold? Oh, uncomfortable. So do you have any exponents? You have 2 of them. And the plus sign will come together as multiplying. What about this plus sign? That'll stay there because this is log of, this is one like group. Do you know what I mean? It's not like a log separated with, log separated with the plus sign where it comes back together. All right, so I'm going to rewrite this as log. What's the base, even though I can't see it? 10. All right, so how does 1/2 log of x come back together? X to the 1/2, which is the square root of x. That's the square root of x. Yeah, once you put them back together, just like before, we're like, wait, it's a radical, flip it to an exponent, throw it out in front. Now we're like, oh, throw it back on top. Oh, wait, flip it back into radical form. It's like the complete reversal of what we just did. Right? If I go step by step, that becomes log x to the 1/2, which becomes radical x. And then the plus sign becomes multiplying. And I'm multiplying it by what? X plus 1 cubed. Do I need to actually multiply all of that out? No, you don't have to. It's not pretty, but did we do it? We did. It's just using those properties, throwing the number out in front back as an exponent, simplifying where you can. All right, let's do this last slide, and then we'll call it good for the day. Okay? Do you guys want to try this top one by yourself? All right, try this one by yourself. All right, guys. So 2 log of x plus 2 minus log of x. So do you have any exponents? Yes, you have this 2 that will come back in there. So you'll write this as log x plus 2 squared, right? The number in front comes back as an exponent. That means divide by x. Can I simplify that at all? Can I cancel these x's? No, this one's connected with addition. I can't touch that. Yeah. You wrote log x, like you had a log on top and a log on bottom? That's wrong. When you're condensing them, you should only have 1 log. That's the point of the properties, is to be able to take a single log and like expand, or take everything back to just a single log. Okay. Good question though. All right, let's take a look at this last one then. All right, so we have 1/3. Ooh, there's brackets and parentheses going on there. So since that 1/3's out in front of that bracket, what's it mean about that 1/3 exponent? It's an exponent that goes to what? Everything. Everything. All right, so we can do that, right? We can do that. Should we clean up inside first? Typically, don't know what you do. You typically clean up everything inside of it first. So I'm going to go ahead and keep the 1/3 just for a second. We'll kind of worry about him in just a second. Leave him out in front. So let's condense all this log stuff. So I have log base 2. What is going to happen with the plus sign? Means you're going to multiply them. So I'm multiplying x times x plus 1. Okay. Could I multiply those together? You could distribute it. Do I have to? You don't have to. All right, and then what happens to this 1/3? It's an exponent. But what's 1/3 as an exponent? What's that mean? It's a cubed root. So this is actually log base 2 cubed root of x and x plus 1. Doesn't look quite as frightening. I mean, it's ugly, but as condensed as it does expanded. How are we feeling right now with the basic properties? Horrible? Super easy and a horrible all in the same class. All right.